Welcome back. Let's talk about ellipses. 10.4, you have a page to tape into your notebook, tape, glue, staple, whatever. Just stick it in there for the long term. So we have two ellipses here on our picture. We have one that is oriented horizontally. This we call a horizontal orientation because it's more left-right than it is up and down. So this ellipse here on the right would be considered a vertical orientation, oriented vertically. So the thing with ellipses is that you have a major axis and a minor axis, and then you have 2 points called the foci. So what's cool about these foci, right here and right here, foci is the plural of focus. If you were to, and in fact my high school trig teacher did this, he took 2 thumbtacks and stuck them right into the chalkboard at each of these focuses, and then he attached this long string. He took his piece of chalk and he made the string taut, and then as he moved the chalk through this path of the string, we got this elliptical shape because as you move your chalk or your marker or something through this path, the foci, the distance of these foci from the center create this elliptical shape. So I very clearly remember the day he did that, and I wish I could do it for you, but you know, they really don't want me to stick thumbtacks in my smart board. Lame. Anywho, focuses are, the plural of focuses is foci, and they're inside your vertices. Okay, so just a few other pieces of vocab. These are the vertices. Now we have co-vertices as well. These points up here are considered the co-vertexes or vertices for plural. We have our center, major axis, minor axis. Just 2 other things that I want to point out before we talk more specifically here. This is value A, and that's value B. Now over here on your vertically aligned ellipse, this is A and that's B. I think that's all I really need to say. We are ready to fill in this handy dandy chart. All right, so the middle column will refer to the horizontal ellipse, and the far right column will apply to the vertically oriented ellipse. All right, so first of all, let's fill in our standard equation. So our standard equation is going to look like this: x minus h quantity squared over a squared plus y minus k quantity squared over b squared, and that's equal to 1. Now, your major axis is going to be horizontal because of our horizontal orientation. Your vertices will be h plus or minus a comma k. So we're going to go from h and we're going to add a, and then we're going to subtract a, and that'll get us along this major axis. And then notice k doesn't change. Now your co-vertices, on the other hand, will be h comma k plus or minus b. And you can see that that's up here on the diagram as well. So we're going to go up or down a value of b, up or down from that y component of your center. And then the foci will be along the horizontal axis, so h plus or minus c comma k. And then to find c, we have to remember this special relationship. C squared is equal to a squared minus b squared. And honestly, I just had to look in my notes. I forget how those are related, so I have it written down, and I'll always have it there to refer back to. So c squared will be equal to a squared minus b squared. Let's go ahead and zip through filling in the vertical orientation. So if your major axis is vertical, then you're going to have something like this: y minus k quantity squared over a squared plus x minus h quantity squared over b squared is equal to 1. And honestly, if you wanted to put the x part first and the y part second, that's fine. Just keep in mind that your larger value has to be under the y if you're oriented vertically. So then my vertices are going to be h comma k plus or minus a. Notice the difference between this and when we are oriented horizontally. And then your co-vertices are going to be h plus or minus b comma k. Notice a difference in our orientations. And then your foci is going to be h, comma, k plus or minus c. Again, that's right. Again, the relationship between a, b, and c is c squared is equal to a squared minus b squared. All right, so that's that. That's going to be a really handy chart for you to look back at here in a few minutes. So now let's take a look at some examples. In this first example, what is the equation of the standard form of an ellipse centered at the origin with a vertex at -6, 0 and a co-vertex of 0, 3? So maybe you're going to want to look up here and think, where are the vertexes? Where are these co-vertexes? What are we talking about? Okay, well, let's make a picture. Let's see if we can do that. So I'm centered at the origin. H and K will be 0, 0. I have one vertex over here at -6, 0. That's my vertex. And then my co-vertex is up here at 3, and that's a co-vertex. So here is one portion of that's like 1/4 of my ellipse. I can just use some symmetry and kind of finish out 2/4, and then come over to +6, and there's the other half of my ellipse. Okay, looking good. So clearly this is oriented horizontally, so I'm going to look in that middle column of my chart, and I'm going to have x minus 0, so quantity squared, over 36, plus y squared over 3 squared, which is 9, and then equals 1. So, done. So what did we do here? We practiced working with our vocab, covertex, vertex. We kind of lucked out because we were centered at the origin, making h and k 0 and 0. All right, done. Next example, example 2. So here we're looking for the foci of the ellipse with the equation 2x squared, or 25x squared, plus 9y squared equals 225. Graph the ellipse. All right, so right now this is in general form, and we want to convert this to standard form. So to convert this to standard form, I'm going to go 25x squared plus 9y squared equals 225. I'm going to divide everything by 225. Divide everything by 225. So this becomes x squared over 9 plus y squared over 25. So I just, on my calculator, I went 225 divided by 25, and that gave me 9. In other words, 25 over 225 simplifies down to 1/9. Okay, next up I need a rough sketch. So here is my rough sketch. I think I can make a straighter line than that. All right, so I'm going to go over 3 in both directions, left and right. I'm going to go up 5 and down 5 in both directions. And there's my ellipse. Oh, that was a bad picture. So here's my ellipse. And that's -5, of course. Okay, like so, whatever, good enough. There's my ellipse, but I need the focuses, the foci in plural. So my foci are going to be along my major axis, always, always, always. Keep in mind that this distance right here is C, and this distance would be -C. Now, from 5 to the origin, that's A. This would be -A. And then just for the fun of it, we could say that, you know, this business right here is going to be -B and then +B. But I don't want to make that any more messy than it already is, so I'm going to actually delete that. Oh, I'm going to delete that light blue. Okay, so we need some foci. We are talking foci. So at this point, my foci, and if I look back at my chart here, I can kind of cheat my way through this. It's vertically oriented. So my foci are going to be h, comma, k plus or minus c. So h, comma, k plus or minus c. Well, since my ellipse is centered at the origin, h is 0 and k is 0, but I need to figure out what c is. So the relationship between a, b, and c is that c squared is equal to a squared minus b squared. So c squared is equal to 25 minus 9, 5 squared minus 3 squared. And so that's 16, and making c equal to 4. So 0 plus or minus 4. Or in other words, my two foci are at 0, 4, and 0, -4. Done, and I already graphed it. So I'm good to go there. All right, one more equation, or one more example, I mean. One more equation to be written. So with this one, I have an ellipse, and I need to write the standard form equation of the ellipse. Again, it is vertically oriented. Since it's vertically oriented, I'm going to have y squared over something plus x quantity squared over something is equal to 1. My center is here. So h and k are -2 and 5. So h goes here. That's going to be a +2, and this is going to be my y minus 5. Okay, so again, think about these in terms of zeros. If you set that equal to 0, you'd have y equals 5. If you set x plus 2 equal to 0, you'd get your x equals -2. Okay, then from your center up to here, this is going to be your a value. So I'm going from 5 to 8. So from 5 to 8 is 3, making that 3 squared, making it, eventually it'll be 9. Now, for B, my horizontal distance to get from the center to one of these co-vertexes, I'm just going to go 2 units. So that's going to be 2 and then squared, so 4. You can go ahead and leave your equation right like that, or if you want to call 3 squared 9 or 2 squared 4, that's good. I don't care. That's good. I'm going to sign off, though. Good work. I hope you're enjoying these conic sections as much as I do. All right, see you later.